Hello there. This lesson is going to be in Chapter 2, Section 10, and it's under the troubleshooting section, but we're going to be looking at specifically testing of a diode. I know we went over this already, but we're going to go over it again just to make sure, because there are some questions that will be on a quiz later that you need to know. So I just want to make sure that I go over this just to make sure that I want you to do well on the quiz. So anyways, testing a diode. So we're going to be looking at two different ways of testing a diode. The one is with, both of them are with multimeters, digital multimeters, which are DMMs. And so one of them is going to be using a digital multimeter that has a diode test setting built in. And then there's also meters that don't have that available. So we're also going to look at using just a ohms setting on a digital multimeter. So either one of them can tell you if a diode is working correctly. So with that being said, we've already talked about the DMMs with a diode checker. One that if you don't have that, you can use just a ohms tester. So with that being said, the other things you need to keep in mind is with a diode, remember it's forward biased and reverse biased. So in this, your red lead on your meter, and this doesn't matter if it's if you're using a diode tester or an ohm meter, it makes no difference which way you're going. So you need to make sure that you understand that the red lead on your meter is the positive lead and the black lead on your meter is the negative lead, because when we go to test this, that is very important. So as we go through this right here, hopefully it'll make perfect sense to you. So again, it says a multimeter can be used as a fast and simple way to check a diode out of the circuit. So that means that out of the circuit, because you got to be careful, because if it's in the circuit, you could get misreadings based off other components that's in that circuit. So you got to be very careful about trying to test something while it's in the circuit. So this right here is saying that if you pulled the diode out, so it's almost like if we go to the bin there in the lab and grab a diode and put a meter on it. So that's out of the circuit. So it says a good diode will show an extremely high resistance, ideally an open, with reverse bias, and a very low resistance with forward bias. So it says a defective open diode will show an extremely high resistance or open for both forward and bias. A defective shorted or resistive diode will show zero or a low resistance for both forward and reverse bias. An open diode is the most common type of failure. So right there it gives us a bunch of information, and it's good information. So let's look at the first thing. We know that the end that has the stripe on it is the negative side, which is the cathode of the diode. So we're going to be putting the black lead on that side of the diode and the red lead on the opposite side. So that means that we're forward biasing the diode. Okay, so what it's telling us is that if we're just using a meter, an ohm meter, it says a good diode will show an extremely high resistance, which means, you know, when it's in reverse bias, it should be like an open, a switch. So it should be really high, if not OL, and a very low resistance when it's forward bias, which means that it's closed. So you may have resistance showing, so it ain't going to show like zero, or it ain't going to, if you always listen for the beep, then you may not get the beep, but you should see a resistance other than a high resistance or OL. So that there means that it's going to be good. But it says if a defective open diode, so that means that if it's open, that means no matter which way you turn the leads, no matter which way you connect them, you know, you reverse the leads and then swap them again, either way you set the leads, that it's going to show a high resistance both ways. So that tells you right there that the diode is open, because you expect it on the reverse biased, but forward biased you do not expect it. So if you do have high resistance or an OL in the forward bias position, then you have an open diode, which is, like it said, the most common type of failure. Okay, so it says a defective shorted or resistive diode. So anyways, remember, we've talked about this before. An open and a short is two different things. An open means that it's open. Short doesn't mean that it's open. Short means that it's actually touching. So that there means that a defective shorted or resistive diode will show 0 or low resistance for both forward and reverse bias. So what that means is that in forward bias we expect it to be lower resistance or very low resistance, but in reverse bias we expect it to be high resistance or OL. But in this case it means that in both ways, no matter which way we have the diode biased with our meter leads, it is showing very low resistance. So you can already see that if you get both ways that you've got it biased, if you see it high resistance, you know something's wrong. If you also see, no matter which way you have it biased, you see that it is closed with very low resistance, you know something's wrong. So right there tells you that you should, one way and the other way, you should get something different, something totally different. And if you don't, you automatically know there's something wrong. So it's up to you to figure out what it is. And either way, if it's shorted or if it's open, the main thing is that you don't want it in your application because it ain't going to work for you. So it goes into a little more detail about the DMM diode test position. So it says many multimeters have a diode test function that provides a convenient way to test a diode. A typical DMM, as shown in figure 276 of this text, has a small diode symbol to mark the position of the function switch. So if you look at your meter and you don't see the symbol of a diode, and by now we should all know what that looks like, then your meter does not have that function on it. So you would have to do just a regular ohm test. When set to diode test, the meter provides an internal voltage sufficient to forward bias and reverse bias a diode. So what that means is that the meter itself is going to provide what voltage is necessary to do the biasing correctly. That means it is built specifically for that purpose. So it says this internal voltage may vary among different makes of DMM, but 2.5 volts to 3.5 volts is a typical range of values. The meter provides a voltage reading or other indication to show the condition of the diode under test. Okay, so it gives you here a couple things to look at. It says when the diode is working, it kind of tells you some of the things you should see. So it says the red positive lead of the meter is connected to the anode, which is the positive side of the diode, and the black negative lead is connected to the cathode, and that there is to forward bias the diode. If the diode is good, you will get a reading of between approximately 0.5 volts and 0.9 volts, with 0.7 volts being typical for forward bias. And also, you may also see on there, instead of seeing a 0.5, you may actually see 500, and that's in millivolts. And remember, this right here is in standard form, so if you was to go to 500 in engineering, that's going to be 500 millivolts. So 0.5 volts is the same thing as 500 millivolts. Some meters will show it this way, actually in volts, and some will actually show 500, and it's in millivolts. And typically where you see it is around this 0.7 or 700 millivolts. So don't be alarmed if you get something that says 500 or 700 or something like that there. It's probably reading it in millivolts. Okay, so it says in figure 276b, the diode is turned around for reverse bias. So we already did forward bias, now we're going to turn it around. And it says if the diode is working properly, you will typically get a reading of OL. Some DMMs may display the internal voltage for a reverse bias condition. So here you can see when it's forward biased, you should see something around this 0.7 volts. When it's in the reverse bias, you should see an OL. So you see, one way it's totally different than the other way. So you automatically should know that it's good. Okay. Now, when the diode is defective, so this right here is when the diode is working. So now if one is not working, when a diode has failed open, you get an out of range OL indication for both the forward bias and reverse bias conditions, as illustrated in figure 276C. If a diode is shorted, the meter reads 0 volts in both forward and reverse bias, as indicated in part D. So look at it this way. If you get the same kind of readings in both directions, it's bad. Don't matter if it's OL or 0 and 0. If you get the same readings in both directions, it's bad. You should get some type of a different reading. Just understand what's typical, which is this 0.7, and OL if it's working, if you're using a diode test. So the next one will be checking a diode with an ohm meter function. So the DMM that do not have a diode test position can be used to check a diode by setting the function switch to an ohms range. For a forward bias check of a good diode, you will get a resistance reading that can vary depending on the meter's internal battery. Many meters do not have sufficient voltage on the ohm setting to fully forward bias a diode, and you may get a reading of from several hundred to several thousand ohms. For the reverse bias check of a good diode, you will get out of range indications such as OL on most DMMs, because the reverse resistance is too high for the meter to measure. So again, the ohms reading is not as accurate as a diode tester, but you still will be able to see the difference from one direction to the other direction. If you get the same readings both directions that you have it biased, then you know something is not right. You should be getting something different both ways, and that should tell you that it's good. So let's keep reading here. It says, even though you may not get accurate forward and reverse resistance readings on a DMM, the relative readings indicate that a diode is functioning properly. Again, it's general. If they're different going both ways, then more than likely it's good. If you get the same reading regardless of which way, then you know it is definitely bad. Because regardless of a diode test or an ohm meter test, you should not get the same readings when you reverse your leads. So that's the main thing. So with that being said, make sure that you get familiar with this. Make sure you understand what DMM stands for, digital multimeter. Make sure you understand that. And here's some of those pictures, some of those diagrams, illustrations that it was talking about what you should typically see. So this right here will be on a quiz. So just make sure that you know this stuff or know where it's at. So if you have any questions, please let me know. Thank you.